This tech tip video looks at how to simulate seasonal foliage variation in accordance with BR209 Appendix G. We'll consider a tree outside of a single room as a simple example. We start with an existing model, where we use the Place Landscape Object button to place a tree outside the exterior window of one of our model spaces. If we want to represent foliage other than trees, we can use the Draw Plane command to draw any 2D plane. We can assign an object type of vegetated shade to our plane, where we want them to represent trees, hedges, or any foliage, for example, as part of a boundary. Once we're ready to run our simulation, we switch to the Radiance application. On the Simulate tab, under the Advanced Simulation type, we can select either BR209 Illuminance or BR209 Daylight Factor. We'll start by looking at the Daylight Factor option, because Daylight Factor uses a simple calculation method that captures a single moment in time. We use the Seasonal Foliage option, where we can input seasonal foliage values. These are used to represent the seasonal change in transmissivity. The winter value is higher than the summer value because when the trees lose leaves in winter, the reduced foliage allows the transmission of more light through the tree. We keep the ratio of red, green, and blue light constant, as the tree does not filter any particular color spectrum of light. It's important when using the Daylight Factor method that we also go to the Sky Eye tab and set the sky conditions to standard CIE overcast sky. Now we can select all of the rooms in our model that we want to analyze and click Simulate. We can see that the software is automatically running two simulations, a summer simulation and a winter simulation, in accordance with BR209. Once the simulation is complete, we go to the Working Plane Grid tab, where we select our results file and then move down a level of decomposition to view our results on a space-by-space basis. For the summer results file, we can see that our average daylight factor is 1.72, with 25% of our space above our target daylight factor of 2. To change our target, we simply have to change the value for low DF to our desired target value. For the winter results, we can see that our average daylight factor is 1.81, with 27.71% of our space above our target. This simulation was run with the tree in place, but we'd previously run a Daylight Factor Appendix G simulation before the tree was added, so that we can now compare the results to see the impact of the seasonal foliage shading. We can see that with no tree, both summer and winter results have a higher average daylight factor, as there's no obstruction to reduce daylight. We'll now look at the BR209 Illuminance method. Illuminance is a dynamic simulation performed for every hour of the year, so we'll check that we have selected an appropriate weather file using APLocate. We also need to set our seasonal foliage, for which we'll use the same values that we set previously. We can then select Simulate, which will run an annual simulation for our selected spaces. Once again, we can see that this performs separate simulations for winter and for summer. When the simulation is complete, we go to the Dynamic Results tab, select our simulation file, and choose how to process our results. Here, we enter what time of the day we want to process our results for, and also input our target result values. We can also set which months we want to set as summer versus winter, with yellow indicating summer and grey indicating winter. This lets us perform calculations for either hemisphere. We click on OK, and the results file will be processed. Once this is done, we follow the pop-up instructions and go to the Working Plane Grid tab to access the processed results. Next, we choose the criteria by which we want to evaluate our results. There are several result bands based on the targets that we set when processing our results, and the varying percentages of time for which these are met. We can either view the pass or fail metrics for the different targets, or we can further edit the band scales and colors used in the visual display of average lux values. This is how we would simulate seasonal foliage variation in accordance with BR209 Appendix G and view the results displayed on our VE model. Thank you for watching this quick video on tech tips.